So this rather plain looking slide, rational functions and their graphs part 2, we're going to look at horizontal and oblique asymptotes. Okay, so in the last one we talked about vertical asymptotes, we concentrated on it, but we also did notice they have horizontal asymptotes. Well, rational functions can have something called an oblique asymptote, something that's at a slant. There are 3 types of horizontal asymptote, and notice the 3 situations that occur for different types of horizontal asymptotes. So we're going to concentrate here on the exponent because this is going to determine how you find your horizontal asymptote. So notice that the numerator has the nth degree polynomial while the denominator has the nth degree. So if your numerator has a degree that's less than the denominator, then the x-axis is the horizontal asymptote. So in other words, your y is going to be equal to 0. If your n and m, if those degrees are equal, then the horizontal asymptote is the line that is the coefficients in front of your 2 polynomials. Okay. Then last is if your n is greater than, in other words, if you have a polynomial up here in the numerator and that is greater than the degree that is in the denominator, there is no horizontal asymptote. Okay, there is a slant, diagonal, or oblique asymptote. All right, let's see what these look like. Examples for a y equals 0 horizontal asymptote, in other words, the x-axis, is one of these, 4 over x squared plus 1. The horizontal asymptote's at y equals 0 because notice the degree here is a degree of 0. Okay, there is no x. And down for the denominator, we have a degree of 2. Okay? All right. Let's look at our next one. Notice here we have a degree of 1. This is a degree of 2. So again, the horizontal asymptote is y equals 0, or the x-axis. Okay? And again, in the second example, 2x is a degree of 1, while 3x squared is a degree of 2. Okay? All right. Let's take a look at when we have examples of when our horizontal asymptote is y equals a over b. Okay? So notice we have a degree 1 and a degree 1. So our degrees are the same. Notice that we have a 2 for my a, and then the b, of course, would have been 1. Okay? So that means that the horizontal y asymptote is y is equal to 2. Again, look here, and our degrees are the same. And this time, it's 5 over 2. Okay, because a is 5 and b is 2. Okay, so what similarities do you see between the problems? The degree of the numerator is the same as the degree of the denominator. Horizontal asymptote is y is equal to 2 for the h of x, and the horizontal asymptote is y is equal to 5/2 for the g of x. Examples for a slant asymptote, okay? Notice that this degree is 3 while this degree is 1. Over here for the next one is this degree here is 2 and this degree is 1 as well. So we don't have any horizontal asymptote for either one of these. All right? So when the n is greater than m, there is no, there is a slant asymptote. All right. Asymptote summaries. The graph of f has vertical asymptotes at the what of the denominator. We worked with this in the last Ed puzzle. That's right, it's zeros. Okay, the graph of the f, if your numerator degree is less than your denominator degree, then what type of horizontal asymptote do you have? That's right. Y is equal to 0. If they're the same, if your degrees are the same between your numerator and the denominator, we have, that's right, y is equal to a over b, the leading coefficient over the leading coefficient. And then if the degree is higher in the numerator than the denominator, we have no horizontal asymptote. Okay. Find all the vertical and horizontal asymptotes for the following function. So what is the vertical and then the horizontal asymptote? Okay, vertical asymptote is going to be a -1, and your horizontal asymptote is y is equal to 2. Find all the vertical and horizontal asymptotes for the following function. Vertical asymptote, we don't have one. Horizontal asymptote is the x-axis, or y equals 0. Let's take a look, though, at our slant asymptotes, okay? The graph of a rational function has a slant asymptote if the degree of the numerator is exactly 1 more than the degree of the denominator. And we're going to use long division to find the slant asymptotes. So here's the second use for the long division. Okay, the only time you have an oblique asymptote is when there is no horizontal asymptote. You cannot have both. And so how do we find it? Okay, we're going to do long division. And we don't care about the remainder. So notice here we have x squared minus x minus 2 over x minus 1. Yes, we do have a vertical asymptote. X is equal to 1. Okay, the horizontal, we don't have one. The slant, we do. And so when we go and do our long division, notice that y is equal to x. So this is the part of the equation that's going to give you your slant asymptote. Okay? All right. All right, let's take a look at this example. Again, what is going to be our vertical asymptote? And again, we don't have a horizontal asymptote. Okay, so then we do our long division. Notice that we're going to get an x plus 1. Should be, remember, a 0 holder in here for the x position. Okay, but anyway, this is the part that we look at. Okay, so the slant asymptote is x plus 1. So again, I'd like to remind you that these have to only be 1 degree. So this is a 2 and this is a 1. So there's only 1 degree of difference between these, and we can find the slant asymptote. Thank you for your participation. The end.